Hello and welcome to the Eco Business Podcast. I'm Robin Hicks, Deputy Editor of Eco Business, Asia's leading sustainability publication. On today's podcast, which is sponsored by Danfoss, we're talking about zero carbon cities and how to turn this idealistic vision into a reality. The built environment accounts for 30 to 40% of global emissions. And to cap global warming to 2 degrees Celsius, the world must reach peak emissions by 2020 and become carbon neutral by 2050. And this will include reducing the carbon footprint of buildings as close to zero as possible. To talk about how to do this, on today's podcast, we have Benjamin Tao, who holds the Urbanisation and Planning Strategy seat on the Governing Council of the Royal Institution of Chartered Surveyors, and Vinod Jathani, Asia-Pacific Business Development Manager, Commercial Buildings for engineering firm Danfoss. Welcome to the podcast, guys. So I'll kick off with the first question for yourself, Vinod. So what's your perspective on the task ahead for Southeast Asian countries to keep growing while building in a more sustainable way? Is sustainable growth for the built environment possible in ASEAN?
That's a very good question. Sustainable cooling is essential to meet our climate goals, United Nations Sustainable Development Goals, Paris Agreements, and Kigali Agreement. Around 20% of energy demand in buildings is used for space cooling. The IEA report, that is Future of Cooling, shows that energy demand from ACs is expected to triple by 2050. If not dealt with, cooling-related GHG gases will increase from 8% to 15%. Deploying the most energy-efficient technologies, we can definitely reduce the impact by 50% in energy needs for space cooling. For example, in Indonesia, people living in cities will grow from 55% to 70% by 2050. This means that we have to build the cities of tomorrow in an energy efficient and climate friendly way. In Indonesia, the energy use of space cooling is expected to increase 13-fold by 2050. In Indonesia, again, the share of cooling in electricity demand increases up to 40% until 2050. What are the solutions then in that case? The solutions could be to achieve sustainable cooling, we need to work holistically with proven technologies like variable speed technology, energy recovery, combined heat and power, and integration with renewables, energy efficient and sustainable solutions.
Yeah, a massive undertaking. As you mentioned, the Indonesian figures were particularly startling. Ben, your take on this. Is sustainable growth in the built environment possible in ASEAN, such a fast-growing region?
I don't think it's whether it's a possibility, I think it's a necessity. And we're not just talking about incremental progress here. It's a huge shift that we need. And it's no longer about mitigating climate change. It's now about, because it's already happening, it's now about how do we make it so it's actually limiting it to be more manageable. And that's exactly what that limit of, to below 2 degrees is all about. Now, that sounds quite doom and gloom, but there are some positive stories within the built environment at the moment. Locally in Singapore, for example, over the last 10 years, we've seen a tremendous market shift in terms of energy efficiency, and our actual energy intensity per floor meter here, per square meter, has actually declined. But we need to do a lot more. I'd actually like to highlight certain international projects. The RIBA International Prize, which was picked up in the international press as being the best new building in the world, was actually given to a children's village in Brazil. The recent RICS Cities of the Future competition also had a sustainable solution based in Manila. And these projects have excellent replicability to large parts of our region. And they have great benefits to holistic sustainability. However, these lessons need to transcend barefoot architecture and be pulled into large corporate-based urbanism, namely the high-rise, high-density buildings that we see in those large cities that are growing rapidly. Again, there are some great projects regionally that start to do this. Kampong Admiralty is an example. So it is possible, but we can't just purely rely on the technocentric approach. I'm a strong believer in vernacular solutions. We need to somehow get buy-in from all actors of the built environment, developers, financiers, users, not just the professionals. And I often find that when we talk about sustainable planning, urbanism, and how we achieve these goals, we're often always preaching to the converted. And it's how we actually reach out to the rest in order to start seeing the huge action that we need to have immediately.
Yeah, no, you mentioned Singapore, where we're recording this podcast from. So Singapore quite ambitiously recently announced a strategy for building a nation of super low energy buildings on top of its ambition to make 80% of buildings green by 2030. So question again to you, Ben, it's an ambitious aim, much of which involves retrofitting existing building stock. So what are the sort of challenges involved in doing this and the costs involved?
Okay, that's a good question. I mean, one of the challenges with existing buildings is quite simple. It's there, it's already built, it's fixed. Which actually, on a slight tangent, it leads me to another point that I need to make about new buildings first, which is new buildings need to be given the proper time for coordinated design, which quite often they're not, in the interest of let's build it as quickly as possible, forgetting the fact that they are going to turn into existing buildings and require retrofitting and hopefully be there for the next 100, 200, 300 years. But so challenges in existing buildings, it's quite difficult that rarely are they fully closed. They'll always, or majority of the time, there'll be tenants within them, and they need to go about their daily business. So to work around the tenants in there is actually quite tough. Also, you're dealing with tenants and building users who may have a lower appetite to new technologies and different ways of doing things, such as alternative cooling, whether it be passive displacement, whether you use hybrid cooling strategies, which I'll come on to, I think, as we go on into the podcast. And in fact, I heard today from a large asset owner that some of their properties they converted aircon space into natural ventilated space in their transient areas. And then when they're looking for new tenants to come in, the strategy was to turn it back into aircon space to allow to attract those tenants, because it was one of the sticking points, even though the previous tenants were actually fine with that conversion. So, I mean, in terms of costs, as you're tackling energy aspects, there's always going to be a return on investment. In the built environment, we tend to look too short term. It needs to be a return on investment in 3 to 5 years, which actually, a building's going to be there for a long time. Retrofit cycles, deep retrofit cycles can be 15, 20 years apart. So you can do it in such a way that, you do a deep retrofit and have that longer payback period. And then you'll start to see from a life cycle perspective, it does make a lot of sense. It's just we need to change that view. So yeah, I think that's about it really. The challenges are, it's a physical asset, it exists. But there are possibilities to sort it out, and there are also other ways of doing it through guaranteed performance contracts where you don't have the capital cost up front, so then you pay it through the savings over that life cycle of the retrofit.
You talked about natural ventilation, and we mentioned super low energy buildings. Of course, back in the days of kampongs in Singapore, where there's no aircon, there's all natural ventilation and passive cooling, right? But so over to you, Vinod. Anything you'd like to build on that, the challenges that Singapore faces in meeting its ambitions, and the sort of costs involved in doing so?
Yeah, there are several measures where we can look into this, reducing the energy consumption in terms of buildings and air conditioning requirements. For example, like electricity share of household air conditioner is almost touching to 40% in Singapore, which is pretty high compared to all developed countries. It is pretty clear that we have to do something, and that too very quick and in the cheapest way, that is using energy efficiency as a resource. Then from the government side, we need to set a certain standards, and we need to raise the bar of those standards year-on-year basis. That is minimum efficiency performance standards. And that is proving the single most effective policy for boosting the efficiency levels. Second is the easiest and most available technologies is to improve the efficiency among all other possible ways to improve and reduce the consumption, like renewables or thermal storage. So among all those things or technologies, the energy efficiency implementation is the most easiest way. Then it is also necessary to establish schemes that encourages investment in optimizing and renovation of building, like tax schemes, like how Singapore government from 2019 have implemented carbon tax, and people would be motivated in looking towards the energy efficiency. By working together with all the stakeholders, we can definitely ensure that we cool people while cooling planet as well.
You mentioned cooling, which is just among many of the exciting technologies that building owners are thinking about to green buildings. Vinod, a question again for you. What do you see as the most exciting pieces of tech out there to green buildings now and in the future? What's on the horizon?
Yeah. We need to adopt a full approach in terms of like with energy that goes into cooling the buildings. Like we need to have the reflective paintings, vertical gardens, so and so on. Now Singapore government has implementing the pilot project for HDBs, wherein until now all HDBs were having their own individual aircons. As a pilot project, they are now considering having centralized cooling and then do the billing similar to what has been done for electricity supply, water supply, and gas supply. And that's where we can reduce the energy consumption by almost 40% on aircon systems. And then the other aspect is setting temperatures. Often we have seen the thermostats have been set below 22 degree, and that is unnecessary increasing the burden on centralized air conditioning system. And there were the recommendations to various agencies that we stop manufacturing thermostats below 24. Let's see how it goes well. And then there are certain other factors in terms of thermal storage, and then we can store renewable energy when the sun is not shining and release on high energy demand, and that's how we increase the energy efficiency.
Yeah, right. Yeah, you mentioned a piece of tech that fascinates me is actually not really technology at all. It's plants. You mentioned vertical gardening, and one of the reasons that Singapore is so lush and green, it's a cooling strategy, isn't it? You see many buildings festooned with greenery these days. So yeah, Ben, what for you are the most exciting pieces of tech out there to green buildings?
I actually agree with you on that. A lot of it is actually not technology based at all, but it is going back to the first principles. But to answer the point about from a tech perspective, I've seen some fantastic improvements from passive displacement cooling, which is cooling without a fan. So it's SMU have a fantastic system. I know NTU have tested some systems as well. Hybrid cooling, which is what you would typically use at home on a very hot day, where you set your aircon to say 27, 28 degrees and have a ceiling fan. I mean, it's basic principles, but to have that at a commercial scale or go back to something like that at a commercial scale is something we'll see coming back in. And then most recently, something really exciting was the use of radiant cooling, but without condensation and without causing convection currents. So you could have a naturally ventilated space, but just to take that edge off for those days where it's a little bit too uncomfortable, you have radiant cooling. So it doesn't change the air temperature at all. It just changes the mean radiant temperature. So again, that's a very low cost, very easy to use system. It's in the prototype stages now. So hopefully in the next 5 years, we'll see something quite exciting.
For the uninitiated, sorry, radiant cooling, explain again.
Okay, so radiant cooling. So if you're from a temperate climate, central heating tends to be a radiator which gets very hot and then you feel warm because of it. But that's not just radiant heat, it also has a convection current, which means that the hot air will rise, the cold air comes into contact with it, etc. So it does that. So what this technology is looking at is pure radiant cooling. So it's a bit like how light passes through a window and you can see through it, you see light. So it's the same with the feeling of coolth, that the coolth will pass through the medium, so you will will actually feel a little bit cooler. So if you use a globe thermometer, which measures more than just air temperature, but also radiant temperature, then you'll see that which is the temperature that you will feel, which can be why sometimes you'll feel that a room is actually very cold, but actually it may not be, and vice versa. You could have a very cold temperature set point with the aircon, but be next to a pane of glass which is superheated to the sun, and it feels quite uncomfortable. So there are many components to thermal comfort. So this piece of technology is quite good because it deals with just taking the edge off, and then you use the wind speed, either through mechanical like fans and or natural ventilation, opening a window, and you start to feel nice and comfortable with that. But I'd like to highlight actually that, I'd like to frame this another way. Technology is important. Vernacular designs I highlighted earlier is also more so. I like to hark on your point about in the past. I used to live in a Singapore Improvement Trust flat which was built in 1958 in Dakota Crescent. I never needed air conditioning when I lived there. So my wife and I have never needed it. It was very comfortable, and the knowledge to do that is still there. We haven't lost that knowledge of how to build for the climate. And that was built before you had complex simulation tools to actually allow you to, make the digital mistake before you start to pour concrete. So it's not to say that technology for alternative cooling is not of value. I think it's wonderful, but it needs to be used in conjunction with that vernacular design, be it biophilia, greenery, or just going back to first principles, back to basics.
Indeed, I live in Pearl Bank Apartments, which is a famous building that's soon to be torn down, sadly. But that's the same thing as well, the same principle, because of the way the building's designed. There's no need for air conditioning because there are many ventilation shafts that allow air to pass naturally through the building.
And Dakota Crescent is also, unfortunately, I've heard, the latest I heard is they're going to gazette a couple of units to maintain, but it's one of those key housing developments which actually transformed housing both in Singapore and in the urbanized tropics, because it showed you could actually do relatively high density at the time housing in a very comfortable way for hot climates beyond the traditional ATAP house.
Finn, I'd like to ask you the quickest and cheapest way to green a building, right? Is if there's a low-hanging fruit for building owners of older buildings to consider if they're short of time or money, what would that be?
Yeah, very good question, actually. In fact, there are several factors which we need to consider in order to achieve this requirement and reduce the energy footprint and the carbon footprints. And to begin with, it starts from the architecture point of view. Is first of all, we need to have a lot of shadings, and then reflective paintings, vertical gardens, and we need to consider the right level of insulation. The objective is, first of all, to reduce the air conditioning load. The moment you do this, and automatically your air conditioning load would come down and your energy consumption will come down. And subsequently, we can adopt the latest and newer technologies with artificial intelligence and IoTs so that the cooling demand is met at the right time with the other technologies or the other methods of providing cooling. And then we can also capture the waste heat coming out from several supermarkets, and those heat can be used into generating the air conditioning system through vapor absorption systems. So this is another way of improving the efficiency level and meeting the cooling demands for buildings. So this could be considered as the quickest and low-hanging fruits. And over and above, the new technologies which are emerging out and like improving the efficiency of centralized air conditioning system, which now Singapore government is also considering for HDBs, that is the oil-free technology, wherein it helps in improving the efficiency level by 50% at part load conditions.
Just to build on that, you mentioned IoT, Internet of Things, and artificial intelligence. Presumably there's quite a high upfront cost to installing that in buildings, but then you get the savings back from the reduced load and, as you mentioned, in air conditioning and other building functions that are brought down, right?
Yes, typically now many funding model and leasing options are available, wherein we can see the return of investment instead of 3 years could be extended to 4 years by implementing leasing model and the funding model. And then we still can implement this kind of high-tech technologies like artificial intelligence and IoTs.
Ben, any thoughts on that, on IoT and artificial intelligence and its application to green buildings?
I think we're on the cusp of something with machine learning, obviously the connectivity between devices through the Internet of Things, and with artificial intelligence utilizing a lot of data that's available to help optimize the building. I don't think we're fully there yet, but again, I think we're getting there. As more and more devices are connected, there's more and more data, therefore the learning capabilities become better, which then allow for, improved optimization. But of course, that needs to be taken with a little pinch of salt, because a lot of the smart technologies, whilst I'm an advocate for them, we also need to consider the privacy aspect, the security aspect of them. Who owns that data? What can that data be used for? Is an occupancy sensor, including a camera, which can actually then see what you're doing? So whilst we talk about how this technology is used, we also need to have a kind of an ethical kind of guiding principle on that, and data standards developed on how we're going to use that and what's it going to be used for. I'd also like to touch on, I thought that was a fantastic point about alternative funding methods for existing buildings. The guaranteed energy savings or performance contracts, systems as a service, for example, as well, where you don't actually pay the capital cost. You just pay for the use of the system. So it's like a subscription-based service, or, for a retrofit, you actually pay for that retrofit based on that savings. And it's a longer-term contract. So it's kind of win-win, which prevents those barriers of entry, which we used to have in the older way of doing things, especially in the built environment.
I want to ask, you chat briefly about urban planning. Ben, question for you first. How can better urban planning reduce the footprint of the built environment?
Greatly. Now, I'll be a bit of a devil's advocate. I actually published a paper on the way we do planning in 2013, and it was based on Lionel March's study from the 1970s. I'm not going to bore the listeners.
What's the title of the report so we can...
It's Planning for the Urban Century was the paper. It was published in the Singapore Institute of Architects, Singapore Architect Journal. But I'm not going to bore the listeners with the entire paper. It was quite long. But basically it highlighted there are alternative spatial forms to high-rise blocks that can give exactly the same density in exactly the same land area, but with almost twice as much open and public and green spaces, and at a much lower building height. So you've got greater cost savings there. And
that sounds impossible.
It does, but I did the maths behind it. So unfortunately in Lionel March's publication, it didn't have the maths behind it, but he had the model. So I replicated that model for Manhattan based on today's planning. So I took an area of Manhattan, I put it into a computer model to make it the right size. I was using BIM to do it. And then I did a mass floor. So based on the planning data for Manhattan at the time, I think the plot ratio was about 7.8, which is quite very, very high. So arranging buildings in grids along the size of Washington Square Gardens to replicate Lionel March's experiment showed that actually, yes, I was getting buildings of about 12 stories with exactly the same floor area arranged around Washington Square Gardens based grids. So I thought, oh, this is interesting. But the floor plans were quite deep. So whilst that would work for commercial buildings, it's not going to work for our residential buildings. So at that time, obviously, there's a lot of talk about Punggol Ecotown and how that was being developed. So what I did is I applied the same principles, but to Punggol. And again, it was similar results. I could get buildings of 8 stories high at exactly the same density and still maintaining that 14, 15 meter wide building plan, which allows effective cross ventilation, which mitigates the need for so much artificial cooling. So these blocks have a fantastic potential, because not only do you have a great semi-public space in between them, which can be used for your schools, it can be used for community facilities, you also have a huge roof area. So your surface area to the volume for the roof is greatly improved. So that allows for biophilic design. So you can have your green roofs, which help combat the urban heat island effect. But not only that, suddenly you have a much greater area per building for renewable energy to help offset those energy systems which you then employ to help, create a greater form of comfort, such as your artificial cooling, and then the internet, which we use a lot of, our personal devices, all the productivity-based devices of the modern 21st century, which we use for working. Of course, this is only one solution. I'm sure there's many other spatial planning methods out there. And I don't want to take away from the Singapore planning system or the global planning system, which has seen many things done brilliantly. Singapore, you mentioned already the greenery. I mean, that's something that's absolutely fantastic about Singapore, the amount of greenery in all the urban spaces, which unfortunately a lot of the other cities around the region have lost. And I think that's a testament to the skill and care. And it's not just me. I mean, in the 1990s, Tay Keng Soon published a development guide plan under the Singapore Institute of Architects for Kampong Bugis. And a lot of those points are actually now incorporated into the planning system in Singapore, which is lovely.
Yes, yeah. No, you mentioned Singapore and indeed the genius of its urban planning. Sadly, a lot of forests has had to make way for the built environment. We've got 0.5% primary forest cover left, but nonetheless, it is a lush green island. Vinod, over to you, and a word on the importance of urban planning in reducing the footprint of the built environment.
Yeah, most of the points are being covered already by Ben, and in addition to what Ben did mention about, we can also look into developing the communities in terms of we can reduce the travel time and some mixed kind of developments wherein people are staying and working not very far from, and then they have the schooling and the entertainment also within the vicinity. So the traveling time is significantly reduced. And Ben also mentioned about creating a roof gardens. So there was a better urban planning could be achieved in terms of putting a agriculture production or the farm of mini farms over the rooftop. So that will help us in having some farm requirements.
Yeah, absolutely. That's very fashionable at the moment, isn't it? Urban and vertical gardening. Final question I'd like to ask you guys is looking into the future, right? Obviously, there's some incredible metropolises in Southeast Asia. My question is, what will cities like Jakarta, Bangkok, and Singapore look like by 2050? Obviously, that question's slightly loaded, and there's been a lot of talk about rising sea levels and climate change and the increasing temperature that we're going to see in these cities. Vinod, perhaps you can go first into what your vision is for what those cities will look like by 2050, which is within all of our lifetimes.
Yeah, 2050 is a pretty long time, and much can be done in coming next 20, 30 years. And I'm sure many technologies would be coming up, helping us in meeting our targets. It's pretty vast time from now. However, to reach an ambitious sustainable development goal led by United Nations, that is number 11, we need to implement solutions urgently on this critical aspect. Cooling in megacities such as Jakarta, Bangkok, or Singapore is playing a key role in shaping the future of these cities. But according to IEA, 99% of the households in Singapore are already equipped with the air conditioning system. However, but there are many proven technologies, most of the air conditioning system today, whether the individual or the centralized air conditioning systems are equipped with inverter technology, which is helping in reducing the consumption and the improving on the carbon footprints. And combined with the heat and power today and integration with the renewables can build these cities more sustainable way. And we have the technologies today, we have the hybrid grids. In a way, we can store the energy during nighttime when the peak power is not required, and then utilize it when we have the demand coming up.
Yeah, absolutely. There's an urgent need, isn't there, for more efficient cooling technologies, because I think that the stat is, I think by 2040, that 40% of all of Southeast Asia's energy consumption will come from air conditioning units and cooling systems. So yeah, Ben, over to you. The final question: these cities, what are they going to look like by 2050?
Well, hopefully not like the lost city of Atlantis. Yeah, that is a loaded question. I believe we could be on the cusp of something potentially quite exciting. Equally, we could be on the cusp of something equally devastating. Over the last few weeks, I've seen some pretty interesting. It's been a good start to the year. I've seen some wonderful technological breakthroughs, which will hopefully come to market in the next 5-10 years. But in order
for example,
so as I mentioned, the radiant cooling without condensation, I think that has huge applicability. Because you're going back to being able to use natural ventilation without energy wastage, and then it just takes the edge off to make it comfortable, rather than I need to seal my building up and then have my air conditioning, which deals with my latent and sensible load, my whole cooling load. So, which then has its own IAQ problems and things like that. So, I mean, I at the moment, build it tight, ventilate it right, may hopefully will hopefully soon become not correct in our region, and we can start to be more permeable again, but take out that, but a little bit more comfortable. I think, but in order for our cities to be successful, we need to be better custodians of the built environment. I think we are failing the built environment a little bit. We're doing our part. Again, I say we're preaching to the converted. I think the converted are doing their part, but how do we reach out to everyone? We need to stop treating buildings like commodities. They're not fashion accessories. We can't change them with the season. When they're built, they are there, or they should be there for hundreds of years. So how do we need to start treating them with that kind of level of respect at the design phase, and when it comes to the sensitive regeneration or redevelopment of them. We need developers, owners, tenants, users to take greater responsibility for the buildings in which for the built environment, which they finance or desire. We need our professionals to assert themselves a little bit more. As part of professional ethics, your code of practice, all surveyors, architects, town planners, engineers, all have them. So let's really put into practice what we signed up for all those days when we were in university and now in private practice or in government sector or, NGO sector. I would like to see, by 2050, Singapore, Jakarta, KL, Manila, Bangkok, as a fun, vibrant cities in harmony with nature, the natural systems which they have displaced, and you highlighted that beautifully. I think it's a challenging time ahead. I think it's full of opportunity. It doesn't really answer what it's going to look like in 2050 because, like I say, we're on a knife edge. It's either going to be dystopia, the lost city of Atlantis, or we could be moving to Mars. Or then again, we could have, salvaged it and have absolutely wonderful cities which can build on the foundations that we're laying today.
That's a great place to leave it. So Benjamin Tell, Vinod Jathani, thanks very much for joining the Eco Business podcast.
Thank you.
Thanks for listening. This podcast was hosted by Eco Business at the SDG Co, a co-working space for sustainable development organisations in Asia. Eco Business is the leading digital media company serving the region's sustainability community. This episode is part of the podcast series Tomorrow's Cities, Engineering the Energy Transition, which is supported by Dan Foss. Dan Foss engineers energy-efficient and smart technologies, which enable the world of tomorrow to do more with less. Join the conversation by visiting eco-business.com, follow us on social media, or subscribe to our newsletter. Thanks for listening.